So in section 2 of our video of lecture presentation, we'll talk about a tool that's quite powerful. It was developed and used in quality management. So it's called quality function deployment. But another name for it is also called the house of quality. And it's a communication tool that allows you to take customer requirements and either you could create a new product or update an existing product with that tool. So let's just get a sense of this. So what tends to happen is that you identify what customers want, and then you ask yourself, how can we actually satisfy those wants? And we do some sort of relationship between the wants and the hows. And once we understand that, we get a sense of how important the hows are relative to the wants. And then based on what competitors provide, we consider some new performance standards or characteristics for the product that we want to produce and use that to redesign it. So here's what the house of quality begins to look like. So quality function deployment, house of quality. So this is the basic construct, and it's just a nice visual representation of the things we're talking about. Here's what customers want. We could rate those wants and rank them if we wish. Here's how we will achieve the wants, and then what we can do is we could specify some target values for the hows, and then we could do some technical evaluation of those hows. In other words, how good are we performing right now with respect to those hows. Also, you do some competitive assessment of how good are we doing with respect to what customers require. And you combine all of that information and figure out ways to redesign that product or that service. So here's an example, very quickly. We want to take a camera and we want to sort of design this camera. So your team has been charged with designing a new camera for Great Cameras Inc. The first action is to construct a house of quality. So let's look at this. We'll ask, what do customers want? And here's what they want: lightweight, easy to use, reliable, easy to hold, steady, color correction. So these are some of the things that we want. And when we look at this, we rank them. So reliable being the highest rated, and then color correction being the least rated. Doesn't mean that's not important. It's just that relative to each other, those are the weights that we assign to them. All right. Then next, we look at the hows. So how to satisfy those wants. And you say, well, make sure that we want some low electricity requirements. We'll use aluminum components, which will allow it to be light. Autofocus, auto exposure, really supports the ease of use concept. The paint palette, which supports the color correction, and then the ergonomic design makes it relatively easy and functional to use. All right. So these are some of the hows. Now we're going to sort of assess the relationship between those hows and those wants. So if we were to put the roof of the house over here, this allows us to tell whether or not the relationship between the hows and the wants are either low, medium, or high. So for example, we see color correction. In this column, this was the color palette, and that color palette and color correction are highly related. Or easy to hold, and the sort of ergonomic design is what we're looking at here in this case, right? So that's the roof of the house. This is the house, but then there's a roof of that house as well, where sometimes we have some interest in the interaction between the house, because if we understand that if one how, if we emphasize it, it has a negative effect on something else, we need to be aware of that. So here we're just checking out whether or not the interaction between some of those have strong relationships or weak relationships and so on. So the electricity requirements and the autofocus, there is a major relationship between those, because clearly to focus the camera we need power. And so those two things would be highly related. So I guess from a design standpoint, you just need to be aware of that. So depending on how quickly or how fast you want to be able to focus, your focus time, then it would have implications for your electricity requirements, right? Low electricity requirements might be a useful objective because you may want your battery to last as long as possible. And you can see here auto focus and auto exposure are strongly related, or that the paint palette and the autofocus somehow are also strongly related, all right? Or the auto exposure and the paint palette are also strongly related. The paint palette and the electricity requirements are also strongly related. So these are just some ways of, again, exploring the different aspects or the different components of the design. Now, how do we get these importance ratings down here? We need to get a sense of the house and how important they are, and we do that by sort of multiplying these values right here with the weights. So depending on how we rate them, there were three of them. We could have rated them 1, 3, 5, right? 1, 3, 5, and so if you rate them 1, 3, 5, you can see that this would be a 3. 3 5s are 15, and those two would be 1s. So 15 and 7 gives us a weighting of 22. So it would appear that this is 32, this is 25, 27. In this column, this was color correction. So color correction, not color correction, sorry, the paint palette. You can see the paint palette being a very important aspect of the design. These two, autofocus and auto exposure, are also very important aspects of the design of that camera as well, because they have fairly high scores. All right. In the end, we could, begin to put things together. We are now comparing two competitors, so company A and company B, and we're looking at these requirements and how each of these companies are performing on these requirements. F might be fair, G might be good, P might actually stand for, I suspect, poor or proficient. We're not exactly sure what those stand for, but we could actually decide how we want to rate those. Okay, and then here are some target values for the technical attributes, and this has to do with, for example, as you can see, electricity. This has to do with the autofocus, auto exposure, and here we get into the sort of paint palette, and then here the ergonomic design of the item. So we say a panel ranking, so we'd have a panel actually rank the ease of use of the camera or the ergonomic design of it. And then we have a technical evaluation, which basically says how does company A perform on those, how does company B, and here's where we are. Here where we want to be on those as well. And then all that information is then put together in a single completed house of quality, as you can see. And that is now used by the design team to go forward. So it's really just a visual representation of a redesign or the design of a new product. Okay. Now, once you've completed this first design, there is something called, you have this cascading of the house of quality, where you go from this very first one to now using it to specify what components we will need, and then based on the components, what kind of processes you will use to create those components, and based on the processes, what kind of quality plan you will have to manage those processes. And that's where you see quality comes into that entire picture, and hence it was called the house of quality model. But you start off by actually using it to design a new product or a new service. All right. If you want to get it, if you want to examine how companies actually go into the design process, over time we've had some changes. In the past, pretty much you had a separate department, and that department was charged with the responsibility of coming up with new designs. The danger in that was that the design folks conceived of products and services in one way, but did not necessarily take into consideration what the manufacturing requirements would be. So that created its own issues. Some cases you had a champion, a manager who sort of drove product development, and that of course as well, because this person is really creative, they could drive things, but you still suffer some challenges in terms of whether or not the products in the end were designed for manufacturability. Or you could actually take a team-based approach where you have a cross-functional team with people from different disciplines. Some people look at the costing aspect of it, the manufacturing aspect of it, the supply chain aspect of that. So all of those elements are crucial, and you tend to get a better product in the end. It might take a bit longer because you're working with this committee, but you get a better product because you could try to avert a number of challenges by having all of these team members from different functional areas. And then the Japanese take what they call a whole organization approach, no organizational divisions. So everybody gets involved in the design of that product or service. When you're designing products, it's very important to design them so that they actually create value for customers. And so there is this concept called manufacturability and value engineering. So you look at a product, you want to make sure that it's manufacturable, and it can be manufactured relatively easily, but at the same time it's delivering value and benefits to the customers that will hopefully buy. So if you actually focus on that, on value engineering and manufacturability, some of the benefits that you accrue include reduced complexity of the products, the reduction of the environmental impact, standardization where possible, the improved functional aspects, improved job design, improved maintainability or serviceability of the product, and the design tends to be a bit more robust. Of course, that is these are potential benefits. It doesn't mean that every time you apply manufacturability or value engineering that you will get exactly all of those benefits, but the tendency is to actually get things done. So let's look at an example of how you could do value engineering. You want to really reduce the cost of producing an item. Take a look at this. So you're producing this and you have it made in these two parts and you bolt them here. So you got to pay for this bolt, and then of course you think of the shape, particularly the bottom one, and it looks a bit complicated. Now what if you did this? What if you welded the two parts here? You still get what you're more or less looking for. It's a bit cheaper, but you perhaps could do even better. Now you actually make this section as a straight piece. You now produce this L piece right here, and so it's just if you think about this, it is the reproduction of that piece right here, but with slightly longer bottom part. And instead of making this as an L shape, now you just make this as a straight rod. So now you've reduced the production price to 80 cents. And you can see here in the first design there was this bolt right here. You have a weld and a bolt. Now all you need is just the bolt alone. So in a case like that, by giving some consideration to the value of the item and what it means to the customer, you might be able to actually redesign things a lot cheaper. So focus on design improvement in production, seek improvements leading to better product or a product which can be produced more economically with less environmental impact. So in other words, the whole idea is when you're doing value analysis, ask yourself, do we need to do things the way we're doing it? Is there a cheaper and better way that will still maintain our quality requirements as we attempt to get this done? One of the things that we've seen a lot of these days when we talk about the design of new products and services It's the whole sort of environmental issue. And so design for the environment is now a new subdiscipline under the design field. Um, Companies are designing products so that they are green, and that requires now a whole rethinking of the design process. So one has to ask whether or not you could sort of redesign that product and minimize the environmental footprint. And so we're focusing on the concept of ecological sustainability or stability by ensuring that whatever you produce in terms of products and services does not harm the environment for future generations. All right? Very, very important. And a number of companies have actually taken that on nowadays because it has now become a source of competitive advantage. It's not enough to simply say that we want to meet environmental regulations. We want to be in compliance. We got to go beyond compliance now and say that there is actually a potential for competitive advantage if you design environmentally sustainable products. So we got to look at design aspects, production aspects, and the destruction. In other words, when you are considering designing a product, it's useful if you want to consider design for the environment to consider the life cycle of the product and what happens in each stage. And as you go through that, you figure out how do you ensure that you minimize the environmental impact. So you got to think about the production phase, the actual use phase, and then of course the termination phase of that product, where you get into recycling. And so there's a whole area of study where we seek strategies for designing products so that at the end of their useful life it is relatively easy to bring to either demanufacture them or disassemble them so that the parts and components can be returned to the supply stream as opposed to being tossed out into the environment. So quite interesting. We see Toyota, I believe that is, attempted to make its cars green as possible by looking at a lot of elements of the automobile and redesigning for sustainability. So in terms of taking an ethical approach to product design, when we think of an ethical approach, we're largely speaking of an environmentally sustainable approach. You want to develop safe and environmentally sound products. You want to minimize waste of resources, reduce environmental liabilities, and then you want to ensure that you comply with environmental regulations but in a cost-effective manner. And then you want to be known as an organization that is a good corporate citizen. So in terms of making your products, make them recyclable, use recycled materials where possible, make sure that your ingredients are not harmful to the environment or to people, use lighter components because then you require less energy when you're transporting them, and then of course use less energy where possible to manufacture, and if you could also reduce the materials. You've all heard of the 3 R's: reduce, recycle, and reuse. And so that you could apply those 3 R's in the context of environmental design or design for the environment. Okay. Finally, we just want to talk briefly about the concept of time-based competition. And what we started to see happen is, particularly in the electronics industry, those who are companies who are highly competitive have very short product development lead times, and so they are competing on the basis of time. Product life cycles are becoming shorter, and the rate of technological change is increasing, and that's what's really enabling a lot of this stuff. So developing new products faster can result in a competitive advantage. All right. So you need to, if you're going to design products, then you got to define it, which is first define in terms of what its functions are going to be, come up with some rigorous specs, right, that you will use during the design stage, When you are going to produce the product, you need to then produce it from a set of drawings, and then of course the drawing should specify the bill of materials, what materials are required to actually produce that product. So there are some documents, engineering drawing documents, bill of material documents, and product specs. So here's an example of product specifications for Monterey Jack cheese. US grade AA Monterey Jack cheese, right, shall conform to the following requirements. Flavor is fine and highly pleasing, free from undesirable flavors and odors, may possess a very slight acid or feed flavor. Body and texture, a plug from the cheese shall be reasonably firm. It shall have numerous small mechanical openings, evenly distributed throughout the plug. It shall not possess sweet holes, yeast holes, and other gas holes. So you're beginning to kind of specify what you want for this product, the color, the finish, and so forth. And you would do that in any case. And bill of materials is just an example for a barbecue bacon cheeseburger. So here are the things that go into a barbecue bacon cheeseburger. As you can see, that would be an example of a bill of materials. Quickly, service design. We because products are tangible, services are intangible, and so often we have to come up with a service concept and operationalize that concept. But we must remember that because we're dealing with human beings, and often human beings are part of the service design itself, the quality or the effectiveness of that service will strongly depend on the extent to which the customer's requirements are satisfied. But you can provide a kind of experience for a customer that meet their needs. And so service typically includes direct interaction with the customer. There is an increased opportunity for customization because the customer is part of that, and each customer may be unique. In a case like that, if you're going to do customization, you have to be prepared for reduced productivity. Cost and quality are still largely determined at the design stage. In some cases, you could sort of modularize your product or your service. You could delay customization until the very end, and then of course try to find ways to reduce the customer interaction with the service. Those are things that you might actually consider when you want to reduce your costs but also maintain your quality requirements. So as we said, sometimes customers are involved in the design process, as you can see here. Here, prearranged funeral services. And you have the customer will design what kind of service that they want, and you have delivery. You have here customers are participating in the design of the equipment, or in some cases they're involved in the delivery of that service itself, right? So these are just different ways in which customers participate in service design. In some cases, customers are actually involved in both the design and the delivery of the service. For example, counseling, college education, financial management, etc. So if you think of financial management, you could be involved in designing a financial portfolio and how you want that delivered. In some cases, you want your reports delivered in hard copy or electronically, etc., etc., etc. I just mentioned briefly that one of the things that we observe in a service is a concept called moments of truth. And moments of truth basically speaks to what a customer experiences when they first interact with your product or your service, and that interaction will dictate to a large extent whether or not that customer will actually repurchase your service. So it's very important in a service design or conceptualizing a service that we think of moments of truth and the kind of interactions or the kind of experiences that you want to create for customers, right? And you have different types of interactions, those that actually are distractive, and those that actually is just standard, and some cases where you have enhanced service. So depending on what you expose your customers to, it will affect their loyalty to the service or product that you're providing. All right. So just like products, services could have some specs, and we see here's a bank that it's drive up window, and there's some guidelines for teller service, and and it's actually specified. Be especially discreet when talking to the customer through the microphone. Other people could hear. Provide written instructions for customers who must fill out forms you provide. Mark lines to be completed or attach a note with the instructions. Always say please and thank you when speaking through the microphone, etc., etc., etc. So we could certainly provide some guidelines in this case. So product and service design, just to kind of wrap things up, this is a very important area in operations management, particularly nowadays as technology is changing, customers' requirements are changing, demographics are changing, regulations are changing. Companies have to constantly look for opportunities to redesign their products and services. And in some cases, not just to comply with regulation changes, but to actually look for a source of competitive advantage. And so we must understand how product and service design add value to an organization, and also recognize that many of the other areas in operations management, such as supply chain management, process choices, process design, quality, and so forth, inventory management, HR, all of these areas actually impact product and service design. Okay, so we must not treat that in isolation, but recognize it is intimately linked with the other aspects of operations management.